In this video, we are going to talk about tracing crate in Rust. It is something like log4rs in Java. So it's a logging mechanism. So you can use this library to have logging functionality in your program. So I have a small program here where I'm using info, event, error, some of the loggings. You can see everywhere I'm logging. So let's run this and see how that is. So basically I have this is the main program. I'm subscribing the tracing that is required um, in order to log the details. So this is a small program num and I'm logging error and I'm calling a function shaveyax and shaveyax accept number and we are logging starting a span. Span is uh, to record the flow of execution through a program. Tracing introduces the concept of spans. Unlike a log line that represents a moment in time, a span represents a period of time with a beginning and end. The span is actually active until it goes out of scope. When a program begins executing the context or performing a unit of work, it enters the context span. When it stops executing in that context, it exits the span. The span in which a thread is currently executing is referred as thread's current span. Okay, so you can understand that here we are entering the span and we are going out of scope here. So, and event info is an informational logging, and event is a, this moment is triggering this log. It's not a span, it's on this particular time. And yeah, it's a very simple program. For this, we are importing debug. I think debug is not required. I remove that. Error, I think error is for this error macro. Event is for event macro. Info macro. Instrument, I'm not using this. I'll use this later. We can see then. And span for the span. Warning, I'm using a warning here. And level, yeah, level is for we can define the levels. We'll discuss that too. But this is for just an info level. So it has a hierarchy. Overall thing it will display when we do a info level or debug level or error level span. So having said that, let us run this. So you can see that we are touching here. We got an error log. So it's just highlighted it as red because it's an error. And we are calling this function and it's going to that call. So it's coming here and we have the span and we are entering the span shaving x and info level is displaying this message. This is what its message. But since we are already in the shaving x span, it's displaying this too. And the tracing program and the message. Event is an informational, same span because it's coming inside this. We entered the span, right? So here we entered the span. So it's info also in the same span. So we are getting this. and just displaying the message. And we are coming back. We have a warning. Warning is not in that span, so we don't have that. We just have that message. Info, we just have that message. Shaving some yaks, num equal to 3. Okay, it's just display what is the value of num at this moment. Okay, that's the basic thing. Now let's read through this tracing. So we discussed the basics of tracing, concepts, span. Span we discuss a period of time with the beginning and end. So in this example, we are entering here in the span level trace. Let's see. Yeah, in asynchronous world, um, warning, in asynchronous code that uses a wide syntax, span enter should be used very carefully or avoided entirely. Holding drop guard returned by span enter across dot wait points will result in correct traces. For example, this is async span in for span entering here some other async function, but the wait keyword may yield, causing the runtime to switch to another task while returning remaining in this span. Okay, so that span will be that code will be recorded with the span, but actually it's not in this block of code. Okay, that's fine. And events. Events represents a moment in time. It signifies something that happens while a trace was being recorded. So event record an event outside of any span context. So it's just an event just triggering from here. It's outside of span. And we are starting a span, my span here, and we are entering it and record an event within my span. So this event will be recorded within span. So if you want to try that, did we try that event? So this event calculating, yeah, yeah, see, it's there. It's recording inside the span. But if you really want to do, let's do here an event before entering span. Oh, we have to give the level. So let's give level. So there's debug. I don't know. I'll capture, but let's try. If I'm not set up with debug, might not capture this. Yeah, it didn't capture that debug thing. Yeah, debug is not capturing. Um, let's do it with info or trace. Error. Oh, it's still not captured that event. capture. Okay, then let me change this to info. Info before entering the span. Yeah, info only it's capturing. Info error it's capturing. Yeah, yeah, we will see that too. Subscribers. As spans and events occurs, they are recorded or aggregated by implementations of subscriber trait. Subscribers are notified when an event takes place and when a span is entered or exited. These notifications are represented by the following subscriber trait methods. Event, enter, exit, called when execution exits a span. Okay, so that's what we did here. So if you look at this init, try init, build the subscriber builder. Let's see what's the builder. Subscriber default. What is this one? This one is configures and construct subscribers. Default fields, format, level filter. Return a new subscriber builder for configuring formatting subscriber. This is essentially shorthand for subscriber builder default. Okay, init, yeah. This is this will build a default subscriber. Okay, yeah, that's what that. And in order to start with this, you need to have tracing as well as tracing subscriber crates. And you can see in the GitHub, in the tracing GitHub, it's under Tokyo. And you can see multiple crates they have. We need tracing subscriber and tracing to start with it. But I think these are all some of the features on this crates. Yeah, you can go through this, but yeah, just to start with the tracing and tracing subscriber is enough. Having said that, let's go back to this tracing. And spans and events are recorded using macros. That's what we have used here. Event macro and span macro. Span macro expands a span construct which is used to record a span. The span enter method on that construct records that the span has been entered and returns a RA2 guard object which will exit the span when dropped. Let's see what this stands for. Resource acquisition is initialization, which is a terrible name. Essence of the pattern is that resource initialization is done in the constructor of an object and finalization in the destructor. Kind of a mutex card. Okay, yeah, that's fine. So yeah, they're entering a trace and entering the span. Yeah, yeah. Another thing is this instrument macro. Instrument attribute provides an easy way to add tracing spans to functions. A function annotated with hash instrument will create and enter a span with the function name every time the function is called. The arguments to that function will be recorded as fields using FMT debug. So let's try that and see what's the difference it's making. Instrument. So yeah, tracing, shaving apps. Oh, it's added a new. Okay, so I don't want to keep this thing and this one. Let's see what it is going to add. It should automatically add this thing with that instrument. We'll see. Yeah, it's added. Now let's comment this. Now it shouldn't be adding, it's just info level, right? So there is no span. Yeah, there is no span, so there is nothing added. Now we will uncomment this. So you don't need to explicitly add the spans. This hash instrument will automatically add it for you. Yeah, this same as what you have done here and in info. Yeah, okay, that makes sense. So yeah, we can just keep that. Everything is added. Calculating, yeah, yeah, yeah. For functions which don't have built-in tracing support and can't have hash instrument attribute applied, such as from an external crate, span struct has in-scope method which can be used to easily wrap synchronous code in span. So in scope, yeah, if you want to use Certe something, you can just do info span JSON parse in scope. So let's do that too. Let's do for that we need to import Certe JSON uh, Certe JSON 0.0. Let's do this. Let result equals info span. Info span and is a um, string JSON dot parse dot in scope, and it's yeah, in scope and this function without parameters. Okay, info span. So let's run this and see what it's bringing. Yeah, it's compiling JSON and expected ampersand U8. Oh, and it should be found. Okay, then as bytes. Oh, I should have given B. Info span, not in scope. Okay, let's see. I can import that. Info span. Yeah, let's run this again. Cannot infer type parameter t. I need to give uh, value here. Let JSON. Okay, result unknown. Okay, dot unwrap. Dot unwrap. And JSON from slice. Okay, let accept. Cannot satisfy deserialize. Oh, it. Okay. Error number 6, panicked. Result unwrap. Error value expected value. How come? This one compile. Yes, result. std error here. Let's see if this works or not. And here we'll give okay to return the unit type. And here I will just do this to propagate the error. But what I don't understand is why it's not. Yeah, expected value. Slice. It's not as byte won't work. Okay, then um, as there's a byte thing. Let's see. I can give that. Suggestion B from slice B. Okay, let's do that if that works. Now is from slice JSON from JSON from slice. Oh, it should be. Oh, I think it should be something like this. some key value pair JSON format y byte byte bracket really as slash this outside slash answer slash outside slash and inside slash and bracket b with bracket should be closed here. Okay. I think this is a valid. No, again error. Insert a JSON from slice b bracket slash name s colon slash codes here slash this one codes complete. Do I need a comma? No, I need a comma. Bracket. Oh, really? Okay, then what I can do is let's do j buff equals b bracket slash name slash. Yep, this is enough. I believe this codes is outside. Yep. Then codes semicolon. Okay, now if I give ampersand buff or just buff, will it work? Will it work? Invalid type map. Oh, string won't work, so I should map this to. Okay, let's create a username. Oh, I need to build the serialize thing. Okay, yeah, so hash map. Lit map to hash map string comma string lib map here. Not found in the scope. Wow, really? Hash map. Yeah, collection. Do I need to import this? Let's do this again. Yeah, now it's working. And what we got? No, we didn't get help if this is intentional. Prefix it with result. Okay, that understand. I'll prefix it since we are not using it anywhere. Info span, but info span should be working. Info span was in scope. Yeah, error level before entering span. Before entering span, where is it? Not sure here. So it didn't touch. Didn't show up anything. If you want examples here. Jesus response. For functions, we don't have built-in tracing support, can't have an instrument attribute applied. In scope method, which can be used easily wrap synchronous code in span. Okay, so it's just synchronous span, and let's see, I can do, is it possible to do inform inside JSON parsing? Was possible? I didn't do anything. Cannot compile. Uh, why? Oh, multiple lines are not allowed with. I should be giving this, and this. Hopefully this works. There are multiple lines in that inside that closure. So what is happening um, inside JSON parsing? Okay, JSON parse. Okay, so that way we are getting info level. Hmm. Okay, that's okay. I think that's what they meant. Let's go to events. So events we discuss, event macro. It will trigger this event from that moment of time. Span event macros, configuring attributes. So when you define span, you can configure target, level, and description of the span. I mean name of the span. Event, same target, level, and description or details. You can even record fields. That's what we did here. Num field we recorded. So we can see what is the value of that at that moment of time. And I think that's all. And now I want to discuss, go to these levels. So tracing level. Level implements partial order and ordered trace, allowing two levels to be compared to determine which is considered more or less verbose. Levels which are more verbose are considered greater than levels which are less verbose with greater than levels which are less verbose with level error considered the lowest. Oh, level error is lowest and level trace considered the highest. Okay. Oh, trace is the lowest. Info is in the middle. Error higher. Levels are typically used to implement filtering and determine which spans and events are enabled. Depending on the use case, more or less verbose diagnostics may be desired. For example, when running in development, debug level traces may be enabled by default. When running in production, info level or lower traces might be enabled. Libraries may include very verbose diagnostics at the debug and trace levels. Application using those libraries typically chose to ignore those traces. However, when debugging an issue involving said libraries, it may be useful to temporarily enable more, more verbose traces. Yeah, info is this much. Error. Okay, let's do. Here we did an info. Let's do an error too. Error. Checking checking the details and one trace is there. Yeah, trace is there. Checking trace macro details. Error macro details. Info hyphen. So we can see which one gives more verbose and debug. Debug I am not even getting. I don't know. Some settings should be there, I think, when we should be running this program in debug mode. But that part I'm not sure. But let's see. Debug macro details. Anyway, everything inside that this function on it. Okay, we have this error level. That's what we got first. And now then JSON parse that we got inside this info JSON parsing. And then we are calling this one. So going here, event. It's triggered that event before entering span details and info for same thing. Nothing much, only color difference. And error, same thing. And trace, no, we didn't get trace. We didn't get these two. I think this is lowest. Hmm. Let me run this in debug mode. Run, start debugging. F10. Oh, these two. You don't log anything. Yeah. Hmm. But I was debugging. Tools. Yeah. Okay, let's run this and finish. Okay. So yeah. I don't know. I'm not sure on that. Why the debug? It's a low level one. Maybe it's not going the debug. Trace and debug is not showing up. Okay. Other than that, yeah, let's see what all the traits they have used. Yeah, these are all other crates, uh, but we will concentrate mainly on event record fields. Yeah, tracing subscriber provides subscriber implementation and utilities for working with subscribers. This include FMT subscriber for logging formatted trace data to std out with the similar filtering and formatting to the event logger. Yeah, event logger is another thing. Event logger implements a logger that can be configured via environment variables. Okay, there are a lot of environment variable settings. Rest info. Okay, yeah, this is another great for logging. I think that's all I need to cover in this video. We have just gone through this tracing crate and some of the functionalities and modules inside it and how to use it. And yeah, that's all I need to cover in this video. We will see some other crate in the next video. Thank you.